Right, welcome to class. So we're going to continue from where we stopped yesterday. We started talking about Kubernetes yesterday. We were able to understand that Kubernetes is a container orchestration tool. It helps us to manage, to deploy, to automate, to distribute uh, our cloud-based or cloud-native app. Okay, on Kubernetes clusters. Okay, and we said that the cluster can be made of servers that are either on-prem or virtual or cloud servers themselves. Okay, we talked about the features of Kubernetes, how it is resilient, how it can automate, can self-heal. Okay. And then we also talked about some of the components that we find within the Kubernetes cluster. So we say cluster is a group of uh, made up of servers, okay, that you can have a minimum viable cluster of one control plane, which is also referred to as master node, and one worker node. Okay, we said that our master node has two major responsibilities. It serves as uh, it exposes the rest of the cluster to the DevOps person through the API server, and it also manages and control the worker nodes within the cluster. All right. There are other components within master node like the control plane, like the scheduler, like the ETST, and all of that. Okay. So also within the worker node, we have components like the pod, which is the smallest unit that we can use to deploy containerized app. We also have the kubelet, okay, which is what helps transfer information to and fro the master node and the respective worker nodes. We have the QB proxy, which is the interface through which our customers are able to access the services or the app that is deployed on our worker nodes. Yeah, for all of that. Okay. And then we've talked about the three major components of the Kubernetes cluster: kubectl, kubeadm, and kubelet. Okay. The kubeadm is what we use to set up, is what helps us to set up a minimum viable cluster. Okay. The kubectl is what helps us to interact with the command line interface, Kubernetes, and then we already talked about the kubelet. And from there, we went ahead to set up our uh, our first server, and we installed uh, Kubernetes on it. After we did that, we took an image of the server and we used that image to launch two other servers. So we have three Ubuntu servers that have Kubernetes installed and configured with them. The next thing we did was to now initiate control plane on one of the servers. All right, so to set up the cluster, we realized we have to set up the control plane first, which is the master node. So we were able to initiate control plane successfully on one of the cluster, and that particular server now becomes the master node. Having done that, the commands that we can use to add other servers to the cluster, either as another control plane or worker nodes were generated. Okay, so we added the two other servers to the cluster as worker nodes. So when we did that, we confirmed from the master node through the kubectl get nodes, and we realized that we now have a 3-node cluster, one master and 2 workers. However, they are not ready yet. Okay, so we play around one or two other commands, how to generate tokens, since we know the token we use to add nodes to the master and nodes to the cluster are only valid for 24 hours. So how we are going to generate new tokens, and even with print commands, we showed us that. And if we decide that we no longer want a particular server to be part of the cluster, showed us how to drain it from the master nodes, okay, and then how to delete it. And also, if we decide that we do not want the entire cluster, we want to decommission it, it also showed us how to reset it. And everything we were doing, we saw yesterday that we were doing it from the master node, okay? And that explains when we said you as the DevOps interact with the entire cluster through the master node. You do not interact directly with the worker nodes. You give instruction to the master node, and the master node transfers your instruction adequately to the worker nodes. Right? So after class yesterday, I terminated the 3 servers. So with the confidence that I have the AMI. So just before class, I'd already launched 3 other instances with the AMI that was generated yesterday, which is what you see currently on your screen. So the next thing we're going to do is to SSH into those servers and then set up our cluster again. Okay, so do you have any question?
I just wanted to talk about monocube. What is it different from this cluster?
Your line is breaking. I hope you can.
Is it breaking? Can you hear me?
Okay, yes, I can hear you now.
What I was saying that maybe if you can throw more light, because I've heard of monocube as a single cluster. I don't want a single cluster. I don't cluster.
All right, monocube
Since,
means you have everything on one server, which is
okay.
it's a single server
But
Kubernetes system. Instead of
okay.
having a cluster whereby you have master node on the server, then worker nodes on different servers. For monocube, you have all that you need to render Kubernetes on one single server, which is
Oh,
really not encouraged for production.
production. Okay. Okay.
Any other question? Are we able to practice yet, or you're waiting to get into the week? Okay, so that we have the three servers up. Can we confirm kubectl version, right? So we have that. Next thing we do, let's initiate on this one, the control plane. So here we use 50.0.0.210 and here 50. All right. Okay. So what do we do next? Let's quickly switch to root. Then we run all of these commands. Okay, so having done that, we copy this and then we come here, sudo su, we paste and we run. We do the same on the second server, sudo su, we paste and then we run that. Okay, so if they come here now to run the command kubectl get nodes, since we have three uh, uh, we have our three nodes. This one is the control plane, which is the master node. And these two are worker nodes. So the next thing we want to do is to get the three of them ready, right? Before we can get them ready, we have to configure the CNIs, container networking interface. Now there is a project called Tigera Calico project. Okay. Project Calico by Tigera. Can you see my screen, everyone? Hello, class.
Yes, you can. Yeah, you can. Yes.
All right. This project Calico by Tigera, an active networking, an active security, and networking solution for containers and Kubernetes. Okay. Project Calico is an open source project with an active development and blah, blah, blah. It was born out of this project and has grown to be blah, blah, blah. Looking for uh, useful information. Okay. Okay. About Calico is a networking and security solution that enables Kubernetes workloads and non-Kubernetes legacy workloads to communicate seamlessly and securely. Okay. So the reason why these three are not ready is because we are yet to network their container interfaces. Okay. So the service that will do that for us is Calico. Another project, they have Flannel. Okay. Uh, Flannel CNI. Okay. Is responsible for providing a layer 3 network between multiple nodes in a cluster. Kubernetes cluster, right? So you either see Calico or you see Flannel, all right? I think I'll give you as assignment to find the differences between Project Calico and then Flannel. Are we together? Did you get the assignment?
Yes, yes. Difference between Project Alico and Project Flannel.
Okay. When you're running in public clouds or on-premise on a single node or across a multi-thousand node cluster, Calico and its pluggable data plane architecture will give you true cloud native scalability that's stable and faster. Which one are we of these four? Public cloud, on-prem, single node, or across a multi-thousand node cluster? Which one do you think we are on?
We're in the public cloud now.
We're on a public cloud. Good.
Yeah.
Are we on a single node?
Not single node. No, not single node.
We're on a what?
We're not
A node
multi
cluster.
node cluster. Yes, we are more than
Okay.
one.
A single node is what you are asking about. The
Yes,
mini
monocube. Yeah,
mini
the mini
qubit.
cube.
Okay. Good.
Yes, yeah.
So look at different architecture here now. Node 1, node 2, okay. Pod within your node, okay. Then the container network interfaces, which Calico binds to, okay. And then the two now, see the control plane here is coming. Let me see if I can reduce this. Okay. This is your control plane, which is also your what?
Master node.
Master node. Thank you.
Mm.
Worker 1, worker 2. Without even telling you worker 1 and worker 2, what do you see in these two nodes that will tell you these are worker nodes?
I think the presence of a pod.
Pod, beautiful. You
And
can only find pod in what? In worker nodes.
the worker.
Pods
Yes,
are not
they're pods.
deployed in control planes.
Control plane. Yes,
Pods
yeah.
are deployed in where? In worker nodes.
Worker nodes. Yeah.
And which component on worker node helps the customer and our client to be able to access application on the worker nodes? QB what?
Proxy.
QB proxy. Thank you.
Proxy. Yeah.
Okay. These are very simple technical interview questions. Okay. So your control plane, your master node, your worker nodes, okay? And then your worker node, through your control plane, you activate the CNI on the worker nodes. All right. Choose a data plane. We're obviously using Linux. Okay. Before now, there is just a very simple YAML manifest that we apply, and then it sets up a Calico project for us. Okay. But that was discontinued early 2020. Is it 22 or early 2022? Yes. Okay. Before uh, then, we have a, a YAML manifest hosted on Google. That is Alphabet Incorporation. But now Kubernetes has parted ways with, not really parted ways, but they have separated their repository from Google because Kubernetes is Google's project. Are you all aware? You may not know what it's Google's project. So they used to have their repositories hosted on Google, but now parted ways, they are now their own. So because of that, the YAML file we normally apply that activates Calico. Now cluster no longer work. So we come directly to Calico to come and get uh, the YAML files directly. That's what I will show you right now. Okay. Look at this about Calico. What is Calico? You get the necessary information here. But how did I get here? I searched for Tigera Calico project on Google, and it brought these two. Okay. And this one, Calico products. If I right click and open this, let's see where it takes us. Okay, if you click on get started, let's see where it takes us now. Okay, this is showing us Calico documentation. Calico open source, Calico. Let's try Calico open source. Yep. So this is where we are. Okay. And then if you look at here, if you expand install Calico, on which of the platforms? Kubernetes. Okay. So look at it, Calico, Kubernetes. First, the system requirement. Do you want to check the system requirement? The node requirement, 64. This is architecture. It is 6 to 64. Okay. And then Linux kernel 3.10 and later, you must be on Red Hat Linux 7, CentOS, Linux, Ubuntu, Debian. Okay. So any of these Linux distro upward. Okay. Our own is Ubuntu what? 20, I think we used to 22. Okay.
22, yes.
Yeah.
Yeah.
And then what else? Network requirement. This is what we are about to set up. We have 6443 opened. We have etcd as well. Okay, so let's go. Okay, I think we met all the requirement that is here. Next, quick start for Calico on Kubernetes. Quick start for Calico on Kubernetes. Again, it says we must have a Linux host that meets the following requirements. We have this, 2 CPU, we have 2 gig RAM, we have 10 gig, we have, I think our storage size is 20, yeah, and any of these distro of Linux, okay? Ubuntu 18.04 and upward. That's the clause you see here, okay? So how do we do that? Follow the Kubernetes instruction to install kubeadm. We already install our own kubeadm. So if you click here, it's going to open another tab for you and show you how you're going to install kubeadm. And we know what kubeadm does for us, don't we? Okay, helps us to set up the minimum requirement, which we have done all of this. Disable swap, done all of that. We've run container CRI, we've done all of that. So we no longer have any business here. Okay, this is from the Kubernetes website. Look at it here, kubernetes.io. Okay, so let's return. The next thing it says we should initiate kubeadm. We've also done this as well, isn't it? kubeadm for the network. Look at this CIDR. This is the CIDR we also used as well, isn't it? 192.168.0.0 CIDR 16. Do you want us to confirm? Let's go look at the command. Look at it. 192.168.0.016. But there is an information in that place. Can we do some housekeeping here? Let's close the tabs that we do not need. Not sure we need this as well. Look at this. If this CIDR is already in use within your network, you must select a different pod network CIDR, replacing this in the above command. So what they are saying is, if within your network, you're already using this CIDR, then change it. Okay, so what that means is, before you will run this entire command, if this CIDR is already in use, then change. Okay, and this is for pod networking, right? So within this CIDR range now, how many hosts do we have? CIDR 16 gives you how many hosts?
Okay.
Anybody
I think we can
knows?
estimate it. It's 2 power 16 now.
You said?
It's much. It's 2 power 16.
So what is 2 raised to power 16?
Yeah, calculate it.
64,536.
Yes, that's it.
Okay.
Mm.
So, but in AWS, out of that, how many has been reserved?
5 have been reserved.
Beautiful.
Mm.
So, all of this, we've done all of this as well, haven't we? We've done 4, we've done 3. Okay, there's none here that has not been done. So now let's install Calico. It says install the Tigora Calico operator and custom resource definitions. So you see that they have moved this YAML file from Google to GitHub user content now. Okay, it's a YAML file. If I go to this place, there's a lot in paste. Okay, and tap enter. This manifest. Why? Oh, okay. I pasted twice. Just paste once. Do you see it? Do you see that? See where we are. See the scrolling
Oh boy, serious.
thumbnail. It says the Lord in it. So what we need to do is just to copy. Okay. It says due to the large size of the CRD bundle, kubectl apply might exceed the request limit. Instead, use kubectl create or kubectl replace. So what's here? kubectl create
Create.
instead of what? What we should have done is apply this YAML file, but because of time, okay, it might exceed the request limit. So we use what? kubectl create. So
Create.
we copy this. Now, where are we going to run this command? On the master node or on the worker nodes?
You're gonna get the master node now.
Okay. So why?
Just get master node.
Why is it on the master node?
The master node provides how do I put it now? The interface, there's interface with the developer, and that is the API server. It's on the master node.
Beautiful.
That's
Beautiful.
that
So
provides the
everything
interface.
you do on your cluster, information you pass to the cluster is through where? The master node.
Master node, yeah.
Okay, so that's the command here, kubectl create flag F, all of this. Okay, the connection to server host was refused. Did you specify
Yeah.
the
Host
right
or port.
host or port? Yes, we did. Port 8080 opened. Let's go check. Security. Okay, we do not have port 8080 here. So let us add port 8080 to this.
Does it mean that Calico uses port 8080?
Some of the plugins might actually be using port 8080.
Oh, okay.
Custom TCP 8080 anywhere. We see. Okay. So we return here. Then run this. Can we do a quick restart? So this is sudo init 6. Okay. kubectl get nodes. Connection to server localhost. So used. Okay. Let's confirm if AT is being used. Sudo let's start cnlp type and grep for AT. Okay. Sudo apt install network tools. Okay. Net tools. Okay, we've installed net tools. And we confirm. Right, it says port 8080 is not in use. That's why you get that. So can we run? Okay, so it's wrong. 164 memcache could not get current server API group list. kubectl version. The connection to the server was refused. Okay, so let's troubleshoot. Let us go and ask our neighbors. You see what's happening to the network now.